Students, till now we have studied in detail structure of atom. Purpose to know electronic configuration. Why? Because electronic configuration decides properties of the elements. Electrons in atomic orbitals helps us to understand the chemistry. So, atomic orbitals we know. Their orientations, their shapes we know. We can distribute electrons in them by means of various principles. But suppose if atom not there, means if compound is there, then if molecule is there, means if atomic orbital is not there, then what exists? That called as molecular orbital. So what is that molecular orbital? What are the essential conditions to form molecular orbitals? What are their energetics? And how can we distribute electrons in those molecular orbitals? And by the way, how can we explain the various properties of the molecule, ion or compound? For that, new term molecular orbital you need to understand. Let us have a comparative study of atomic orbitals and molecular orbitals. Understanding of atom and its orbital is a story of 2500 years. I am not going in detail, but I like to inform highlights of modern chemistry, means quantum chemistry. Because of the work of Max Planck and Albert Einstein at the beginning of 20th century, people could understand properly what wave actually means quantum chemistry has started there because of the work of Planck and Einstein. Einstein said a wave exhibits dual nature, means wave has particle nature. Almost 20 years after his work, a genius scientist Louis De-Broglie in 1924 said, if wave can exhibit a particle behavior, then why can't particle exhibit in a wave? So he put forward a new idea about matter wave. A matter wave remains always with source. Its wavelength, frequency and speed, those are the variable things. So understanding the matter wave was a challenge in front of the people. Formula to find wavelength was suggested by De Broglie. He said lambda is equal to h upon mv. We were considering wave function as a psi. Psi has no more physical significance other than simple its existence mean we can say amplitude. How to solve that wave function, how to understand that wave function, how to interpret that wave function, it was a challenge. And in 1926, Erwin Schridinger has given one solution to understand that matter wave, understand wave function. So his differential equation could result three quantum numbers in true sense. Fourth quantum number was added by improvement suggested by Dirac. So we could describe now the wave function by means of four quantum numbers. Number one, principal quantum number. Second, azimuthal quantum number. Third, magnetic quantum number. And fourth, spin quantum number. But true understanding about the orbital was happened after the work of Werner Heisenberg in 1927. Heisenberg has suggested one principle. As per his principle, simultaneously exactly we can't find position and momentum. Means there will be the error in the position or the momentum if we want to find them simultaneously. He said there is a certainly uncertainty. Therefore, in spite of fixed or particular trajectory or location of the electron cloud model came out. And where there is a more possibility of finding the electron, that area, that region, that volume is our atomic orbital. S orbital we say. In true sense, S is a subshell or a sublevel which has only one orbital and label is a s orbital. But S should be distinguished by principal quantum number. So we say 1s, 2s, 3s or 4s. Likewise, P is a subshell or the sublevel which has three orbitals px orientation along x-axis, py and pz. Again, 2px, 2py, 2pz, these are the one set of orbitals. 3px, 3py, 3pz is the other set of orbitals. So orbitals we could distinguish by three quantum numbers. Principal quantum number, 1, 2, 3 numbers we provide. Azimuthal quantum number, a symbols S, P, D we use. And magnetic quantum number where particular orientation for that orbital we represent as now I explained Px, Py and Pz. Similarly, you will understand 5d orbitals are there. So whatever this concept of probability of finding the electron, that probability, possibility means there is a no perfect certainty. That concept is a atomic orbital concept where there is a more possibility of finding the electron, that electron cloud region, that orientation, that shape is nothing but our atomic orbital. People have understood the atom and atomic orbitals by electron cloud model. Now they wanted to know the formation of molecule. They wanted to study the chemical bonding, and the approach suggested by these three scientists is praiseworthy, that we say as valence bond theory. They considered the wave approach. They considered the wave function. The one wave function interacts with other wave function to give resultant wave function, and resultant wave function after solution can give us the idea about the molecular energetics and internuclear distance. It was mainly focusing on the valence electrons, outermost electrons. We have studied already the explanation of formation of hydrogen molecule by Hitler and London theory. They have suggested four different improvements. First improvement, exchange. Second improvement, shielding. Third improvement, ionicity. And fourth improvement, resonance. So mathematical base is there for explanation of formation of hydrogen molecule. That is a success of valence bond theory. Contribution of Linus Pauling is admirable. He has explained the resonance concept, he has explained the formal charge, he has explained the bonding in various molecules. This valence bond theory also called as Linus Pauling theory because of his major contribution. So valence bond theory has ruled the chemical bonding world almost for about 30 years. But by 1960s, people come across few shortcomings of this valence bond theory. As per this valence bond theory, oxygen molecule is diamagnetic in nature. I give explanation. Oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. So in p orbital 4 electrons are there. How can we arrange those 4 electrons? In first orbital 2 electrons, second one and third 1 electron. So how many unpaired electrons are present in one oxygen atom? Two unpaired electrons are present. Similarly, other oxygen atom remains with two unpaired electrons. Those two unpaired electrons overlap to produce double bond. Yes, it was right. There's a double bond between the oxygen and oxygen in oxygen molecule. But because of pairing of electrons, it should be diamagnetic in nature. But practically when people have studied the liquid hydrogen, they found it is paramagnetic in nature. Valence bond theory could not explain the magnetic property of oxygen. So people were in need of other theory. Actually, that theory has took the birth 30 years almost in advance. What is that theory? Let us know. It is a combined joint work of Frederick Hund, Robert Mulliken, John Slater, and John Leonard Jones. Mainly, this theory is called as Mulliken-Hund theory. This theory considers the formation of molecular orbitals from atomic orbitals, following one principle called as linear combination of atomic orbitals, which results new wave function, and description for that new wave function helps us to understand molecular orbitals, and by distributing electrons in resulted molecular orbitals following Hund's rule of maximum multiplicity, Bohr principle, and Pauli's exclusion principle, we can understand chemistry of molecule. That's the basis of molecular orbital theory. You will recognize this theory is originated in 1932, but by end of 1960s, we came to know the importance of this molecular orbital theory. What actually molecular orbital theory says? What are molecular orbitals? How do they distinguish from atomic orbitals? Let us know. Yes, atomic orbital is a probability of finding the electron in an atom. Means where there is a more possibility of finding the electron. That jurisdiction we consider as atomic orbital. And how do we represent it? By one function that's called wave function. Symbol is psi. Similarly, molecular orbital is a region where there is a highest probability of finding the electron, but where in molecule. So atomic orbital loses its identity and results new orbital. That's called molecular orbital. It is also represented by wave function. Means whatever our modern quantum chemistry is there, quantum mechanics is there, it is applicable for molecular orbital also. Only how the result can be obtained, how the molecular orbital wave function can be obtained, that approach is different here in molecular orbital theory than valence bond theory. So what is this approach? In case of molecular orbital theory, it is by LCAO principle, by linear combination of atomic orbitals. Atomic orbital is electron cloud around the nucleus. I am not saying electron is revolving around the nucleus. Whatever that concept was there, that is outdated concept now. Now because of uncertainty, we are finding, we are understanding, we are considering electron cloud in various magnetic quantum numbers, in various orbitals. I said s orbital, means 1s orbital, 2s orbital, 3s. In case of P, 2px, 2py, 2pz. In case of D, dxy, dyj, dxj, dx square minus y square, dz square. These are the atomic orbitals, and whatever the lobes or whatever the shape of the orbital we represent, that is an electron cloud. What about the molecular orbitals? They are resulted from atomic orbitals. They are resulted due to interaction between atomic orbitals. They are produced by atomic orbitals. So, genesis or formation of molecular orbital is in atomic orbitals. Wave functions of atomic orbitals, they will interact to produce molecular orbitals. What kind of interaction is considered? That is a speciality of molecular orbital theory. That will decide how molecular orbitals will result. Here, point of comparison is shape. Shape of atomic orbital depends upon whom? Magnetic quantum number. So px, py, pz, dx square minus y square, dz square or s orbital, all they signify one particular shape, and that depends upon ml value, magnetic quantum number value. What about molecular orbitals? It depends upon how atomic orbitals interacts. For example, sigma to pz, pi to py, sigma star to pz, pi star to py.
These are the various orbitals. Means what you are finding, somewhere star is there, somewhere star is not there. Star means anti-bonding molecular orbital. So what kind of molecular orbital results depends upon kind of interaction between the atomic orbitals, and their shapes depends again on the interaction. That is the point to understand here. Point of comparison here is electron density. How can we obtain electron density in an orbital? By means of solution of wave function. How can we obtain solution of wave function? By Schrodinger equation. Whatever we say, no, different magnetic quantum number, it is a result of solution of Schrodinger equation. So atomic orbitals, their electron density can properly be understood by solving orbital wave function with the help of Schrodinger equation. Similarly, if we want to describe the electron density in molecular orbitals, then whatever the resultant wave function remain, that can be solved by Schrodinger equation, and as happened for atomic orbitals, electron density, electron cloud, arrangement of orbital, shape of orbital, orientation of orbital, we can understand. Which orbital I am talking about? I am talking about molecular orbital. Then question arises, how to find that resultant molecular orbital? How to find the resultant wave function? It is obtained by one principle called as LCAO, linear combination of atomic orbitals. Yes, main point of understanding the molecular orbital is linear combination of atomic orbitals of wave functions of respective atoms. When we consider an electron in an atom or molecule, electron is negatively charged. That negatively charged electron is around a positive core aspect. What we say for that? Nucleus. Yes, here point of comparison is number of nucleus or nuclei. In case of atomic orbital, there remains only one nucleus, single nucleus. It is monocentric. But molecular orbitals, many nuclei are possible. It is polycentric. Around two or more nuclei, electron cloud will be there. Molecular orbitals will be there. So that's a difference in atomic orbitals and molecular orbitals. It is very important one. Molecular orbitals are formed from atomic orbitals, but whoever nuclei are there around which atomic orbitals were there, now both nuclei holds attracts electron in molecular orbitals. Therefore, we say atomic orbitals are monocentric while molecular orbitals are polycentric. Chemistry depends on electronic configuration. An electronic configuration in an atom in various atomic orbitals depends on three principles: Bohr principle, Hund's rule, and Pauli's exclusion principle. Depending upon the number of unpaired electrons available, energetics of electron, we decide the chemistry. Similarly, in case of molecules, same three principles we are following. Bohr principle means electron filling takes place in various molecular orbitals from low energy orbital to high energy orbital. Hund's rule of maximum multiplicity means if orbitals are of the same energy, then electron pairing will not take place until all orbitals of same energy are completely half filled. And last one, electrons having all four quantum numbers same are excluded. Here, if we consider any of the orbital, then no two electrons can be with same spin. Means pairing should be there. That's our Pauli's exclusion principle. So here also in molecular orbitals, we have to follow these principles, and this electronic configuration will decide the property of molecules. I hope from this all discussion, atomic orbitals and molecular orbitals comparison is clear to you. As a homework, simple question to you. Only you have to answer in the comment box. Which orbitals are polycentric? Means atomic orbitals or molecular orbitals? I am waiting for your answer.
Now you might have got the insight how molecular orbitals are formed. And molecular orbital also is a wave. That wave function, its solution is important for us. So how to obtain that wave? How to obtain that wave function? I told you in this video by means of LCAO method. Let us study that LCAO method from next part.